Okay. 1.9. Factors of whole numbers. Every whole number can be broken down into smaller ones that multiply together. And the smallest they can get they're called factors. The smallest they can get is called the prime factorization. All right, so what else do we want to say about this? A prime number has factors 1 and itself. Prime numbers from, say, 1 to 10. I can't believe I am admitting to this, but I always forget whether or not 1's a prime number. Studying math for 6 years, I still don't know what I'm talking about. Oh, maybe that's why. Okay, 1 is neither prime nor composite, so it is not a prime number. 2 is a prime number. 3 is a prime number. 4, not a prime number because 2 goes into it. 5 is a prime number. How about 6? No, because 2 goes into it. So basically every even number is out of the picture now. 7 is a prime number. Is 9 a prime number? No, because it's divisible by 3. Okay? So when we talk about a prime factorization, it will be made up of those numbers. Here is your factor tree. I know that 8 is equal to 4 times 2, and then I break down the 4 into all of the prime factors. Then, one last thing. There's a lot of stuff on this slide. The prime factorization of 8 will be 2.2.2, which is 2 to the third. We'll see questions in the homework that say, find the prime factorization of 24, let's say. And you've got to be able to do your factor tree and write out the prime factors using exponents.
So you'll always write prime factorization using exponents?
Yes. Don't quote me on this, but I believe if you enter 2.2.2, the computer would mark it wrong. I believe. So it's like one of those things where you did all the work and you got it right, but if you don't put it in the form they want, they're going to mark it wrong. Anything else on this slide? There's a lot there. Okay. There's a difference between listing all the factors and listing the prime factorization. Start at the smallest number. 1 times 24. 2 times 12. Does 3 go into 24? I think it does. 3 times 8. Does 4 go into it? 4 times 6. Does 5 go into it? No, because the number doesn't end in a 0 or 5. And then by the time you swing back around to 6, you know you're covered because you did all the upper numbers. All right, so that's listing all the factors. How does that differ from the prime factorization? We need a factor tree. So pick two numbers that multiply to 24. Go ahead. Two numbers that multiply to 24. 4 times 6. The 4 breaks down. I shouldn't have put the dot there. The 6 breaks down into 2 times 3. So now the prime factorization use only the bottom branches. How many 2's do I have? I believe that in the homework problem, they would be looking for 2 to the third dot 3. I also want to point out that, say he picked 12 and 2. That would still get you to the same answer when you do your factor tree. So now this one, mine looks like this up here, but it's still the same thing because what are the bottom branches? All right, it doesn't matter which factors you first pick. Next part of the section is what's called the greatest common factor. Of two numbers is the highest factor that both of them have in common. So I think I'm going to change this around a little bit, and I'll do 20 and 24, because we already did the 24. Notice that I didn't do a factor tree to start out, but I listed all of the factors. You have 24 over here to the left. 20 is 1 times 20, 2 times 10, 4 times 5. There are a few things in common. They have a 1 in common, but that'll rarely be a greatest common factor. I think that they have a 2 in common. And they also have 124, a 4 in common here. So if you know all the factors, it becomes really easy to say what's the greatest of them. Sometimes you can just think of it and try numbers. Like, does 2 go into 24 and does 2 go into 20? Yes, I know that. But is there a higher number? Maybe 4 goes into it. Does 5 goes into 20? Does 5 go into 24? No. 6 goes into 24, but does 6 go into 20? No. So you kind of just think about it. I'm gonna also give you the way to do it with the prime factors. We know already that 24 is 2 times 2 times 2 times 3. The prime factorization of 20 is 2 times 2 times 5. Now say to yourself, what prime factors do they have in common? I see 2 and a 2. So I think the greatest common factor will be 2 times 2. All right, so you're basically taking 1 for each pair. There's another 2 there, but it doesn't have a pair, so you just leave it. I'm giving you that way because like the homework throws like 1024 at you and says find the greatest common factor of 1024 and 50. You know, so. Who haven't I heard from? Let's see. Everybody needs choice in life. Do you want to do another one, or do you want to call it right there? Let's do one more. I agree. $64 and 28. How about you guys try it and think about it on your own for about a minute? See if you can come up with 64 and 28. What's the greatest common factor of 64 and 28? 4. Yeah. I took the long way. I went through all my factors. I see a pair here and here. So for each of those, I will say, okay, the greatest common factor should be 2 times 2. That's it.